Hello everybody, welcome into another lesson. So today we are going to talk more about quadratic functions, and this time they are going to be where the coefficient on the x squared term is negative. So here we have the graph of f of x equals negative x squared, a very basic default parabola. The coefficient on the x squared term is negative. It's -1, so when it's negative, it opens downward. The parabola will open downward if the coefficient on the x squared term is negative. If it's positive, like in yesterday's lesson, it opens upward. And then what remains the same is to find the x coordinate of the vertex, you take -b over 2a. So you take the negative of your x to the first term over twice the coefficient of your x squared term. You'll find the x coordinate, and then to find the y coordinate, you put the x value into your function, you'll get the y coordinate. So we will get started with some examples here. Actually, I should keep that x equals -b over 2a up there. X equals -b over 2a. Alright, we'll keep that. Alright. Get started with the first example here. G of x equals -x squared minus 3x. So we have the function g of x equals -x squared minus 3x, okay? So first thing you want to do, like what we did yesterday, find the vertex of the graph. That's going to be x equals -b over 2a. So in this case, the x coordinate will equal, let's see, b, which is the coefficient of your x to the first term, is -3. So you'll have -3 over 2 times the coefficient of your x to the second power term. Well, that'd be -1. Which would equal -3 is 3 over 2 times -1, that's -2. So the x coordinate of this is -3/2, or -1.5. So the x coordinate's at -3/2. Now, we need to find the y coordinate. What you're going to do is put that x value into the function. So I would have g of -3/2, which is going to equal -3/2. Whoops, that'll equal, yeah, the negative of -3/2 to the second power minus 3 times -3/2. Well, negative of -3/2 to the second power, that give me -9/4. And -3 times -3/2, that'd be plus 9/2. Well, -9/4 plus 9/2, that's the same as -9/4 plus 18/4. So the y coordinate will end up being, so you have f of -3/2 is going to equal positive 9/4. So the vertex is going to be, therefore, the coordinate -3/2, 9/4. That would be your vertex, would be -3/2, 9/4. Since when we put in the x value of the coordinate of x squared of a negative 3/2, you get positive 9/4. So now we can plot that point. Negative 3/2 is here, negative 1/2, 9/4 is a little bit greater than 2. So the vertex is right there. And also, remember when we talked about yesterday, that x value for the x coordinate of your vertex, that x equals negative 3/2, that's also your line of symmetry. So I'm going to draw a green dotted line through here to denote that's the line of symmetry. If we remember what the line of symmetry was, basically that's the point where you can take the parabola that we're about to form, you could fold it in half over top of itself, and you would have, it would fold in on top of itself and fit perfectly. That's the line of symmetry. Alright, so we got the vertex. Now we want to find at least a couple points here to plot to form our parabola. Usually you want to find the x-intercepts if you can. So set the function itself equal to 0. Negative x squared minus 3x equals 0. Well, you could factor out a negative 1. You would get x squared plus 3x is equal to 0, which factors into x times x plus 3 equals 0. So therefore, x equals 0 and negative 3. So your coordinates for the x-intercept are going to be negative 3, 0, and then 0, 0. So now once you've found those, you can go ahead and plot those points. We've plotted them. Now you can just form your nice parabola by connecting the dots. And what do you know? There is the graph of g of x equals negative x squared minus 3x. So we found the coordinates of the vertex by taking x equals negative b over 2a, putting that x value into the function. You found the y coordinate. So we ended up coming up with a vertex being negative 3/2, 9/4. Then we ended up having the x-intercepts being negative 3, 0, and 0, 0. We just connected the dots, drew the parabola through them, and there you go. And I do have more examples. Why am I erasing x equals negative b over 2a? I want to keep that. There. But I'll erase the other stuff. Let's erase that line of symmetry. It's not going to be the same in the next one, so all right. What is the next one? F of x equals negative x squared plus 4x. So for this particular function, f of x equals negative x squared plus 4x. Well, let's start. Let's find the coordinates find the coordinate of the vertex. We have x equals negative b over 2a. So in this case, you'll have x equals negative 4, because that's the b is your coefficient of the x to the first term. That'd be negative 4 over 2 times the coefficient of your x to the second term, which is your a. Well, the coefficient of the x to the second term is negative 1. Well, let's see. You end up getting negative 4 over negative 2. So x would therefore equal 2. The x-coordinate of the vertex is going to be at 2. So we can draw, that's also your line of symmetry as x equals 2. So let's go ahead and draw that line of symmetry at x equals 2. Alright, so now we've identified the line of symmetry and the x-coordinate of the vertex. Now all that's left is to find the y-coordinate of the vertex. So all we do is take that x value of 2, put it into the function. You'll do f of 2. That's equal to negative of 2 to the second plus 4 times 2. Well, 2 to the second is 4. You have the negative of that, so you'd have negative 4 plus 4 times 2, that's 8. Negative 4 plus 8, that's 4. So f of 2 equals 4. Therefore, the coordinate of the vertex is going to be 2, 4. That's the coordinate of your vertex, rather, would be 2, 4. So let's go ahead and plot the point 2, 4. That'll be right there. There's 2, 4. That's the vertex. Since we have a negative coefficient on the x to the second term again, this parabola is going to go downward. Which means since it's going downward, what I forgot to mention in the last exercise is that value for the vertex that you put into the function, the y value you get is also this time your maximum value of the function. Yesterday when the parabola opened upward, the y value you got for the vertex of the function was your minimum value when it opened upward. If your parabola opens downward, that y value is the maximum value of the function, since it's going to open downward. Okay. Now, we probably just want to find the x-intercepts, so let's set this function equal to 0. So you'll take negative x squared plus 4x, you'll set that equal to 0. Or you can factor out a negative 1, you'll get x squared minus 4x equal to 0, which would factor into x times x minus 4. That would equal to 0. So therefore x equals 0 and 4. So your x-intercepts are going to be at 0, 0 and at 4, 0. So now we can plot 0, 0 and 4, 0, which would go right there. And now between the vertex and those 2 points, you just connect the dots and you make your parabola. And we can see why the 4 is the maximum value of this function, or in the parabola, because it's at the vertex, it's at the top of it. So this here is the graph of f of x equals negative x squared plus 4x. And you have a perfect line of symmetry going through x equals 2. If you take this parabola, fold it over on itself, it would fold right on top of itself and be a perfect shape. Okay. What's the next one? We have h of x equals negative x squared minus 8x minus 15. So this particular function is h of x equals negative x squared minus 8x minus 15. So let's start by finding the coordinate of the vertex. X equals negative b over 2a, so x would equal negative of negative 8 over 2 times negative 1. Well, negative of negative 8, that's positive 8 over 2 times negative 1, that's negative 2. So therefore, x equals negative 4. So the x-coordinate of the vertex is that x equals negative 4, which means x equals negative 4 is also your line of symmetry. So that's going to go right here. That goes right here. So x equals negative 4 is your line of symmetry. Now, what's left now is to find the y-coordinate of your vertex. So you'll take h of negative 4, put that into the function. That'll give you negative of negative 4 to the second minus 8 times negative 4 minus 15. Well, negative 4 to the second, that's 16, so negative of that is negative 16. Then you have negative 8 times negative 4, that'd be plus 32. Then you have minus 15. Well, negative 16 plus 32 is positive 16 minus 15, that equals 1. So the coordinate of the vertex, therefore, is going to be negative 4, positive 1. So at negative 4, positive 1, that is your vertex right here. Negative 4, positive 1. And also that value of 1 that you got for the y value of the vertex, that is the maximum value of the function, would be 1. Because this parabola is also going to open downward since the coefficient on the x squared term is negative. Next thing I might recommend is finding your x-intercepts. So we'll set the function equal to 0, take negative x squared minus 8x minus 15, set that equal to 0. Factor out a negative 1, you get x squared plus 8x plus 15 equals 0, which this will simply factor into x plus 3 times x plus 5 equal to 0. So you get the x values of negative 3 and negative 5, which means your x-intercepts are negative 5, 0, as well as negative 3, 0. So those would be your x-intercepts, negative 5, 0, negative 3, 0. So now let's go ahead and plot those points. Here's negative 5, 0. Here's negative 3, 0. Now we just simply connect the dots and form the parabola. And that there is the graph of negative h of x equals negative x squared minus 8x minus 15. Alright, what's the next one? We got k of x. So you have the function k of x equals negative 6x squared minus 3x plus 1. So we have the function k of x equals negative 6x squared minus 3x plus 1. Well, let's find the x-coordinate of the vertex. X equals negative b over 2a, so x would equal negative of negative 3 over 2 times negative 6. Which would equal, well, negative 3 is positive 3 over 2 times negative 6, that's negative 12. Therefore, the x-coordinate of the vertex is negative 1/4. So x equals negative 1/4, that is your x-coordinate of the vertex and also your line of symmetry, which is pretty close to 0. I'm not even going to draw the line of symmetry because it's small enough on this and it's close to 0. But let's find the y-coordinate now of the vertex. You'll put in k of negative 1/4. That'll give you negative 6 times negative 1/4 to the second minus 3 times negative 1/4 plus 1. So let's see, negative 6 times, negative 1/4 to the second, that's going to be 1/16. Let's see, negative 3 times negative 1/4, that's plus 3/4 plus 1. Negative 6/16, that's going to reduce down to negative 3/8. You would have negative 3/8. Alright, you have 3/4, that's 6/8. Plus 1, well, that's 8/8. So, excuse me, allergies kicking in today. So you have negative 3/8 plus 6/8, that's 3/8 plus 8/8, that would give you 11/8. So the coordinate of the vertex is going to be negative 1/4, 11/8. That is the coordinate of the vertex. Sorry, guys. Okay, so let's go ahead and locate that point. Negative 1/4 is about here. 11/8, that's 1 3/8, so that'd be about right here. So there's your vertex, and that 11/8 is going to be the maximum value of the function because you have a negative coefficient on the x squared term, therefore the parabola is going to open downwards. Alright, well, let's see here. I don't think this function readily factors very nicely. So at this point, we could put in 2 more values here. Let's pick 2 values and graph them. Let's see, how about when, let's do k of 0. So when x equals 0, well, negative 6 times 0 is 0, negative 3 times 0 is 0, you just get 1. So you'll get the point 0, 1. That's on there. So 0, 1 would work. I plotted that. Now how about when k is 1? Let's just stick in 1, or negative 1, I'm sorry. When k is negative 1, that's going to equal negative 6 times 1, because negative 1 squared is 1. Minus 3 times negative 1 plus 1. Well, negative 6 times 1 is negative 6. The negative 3 times negative 1, that's plus 3 plus 1. So when k is negative 1, negative 6 plus 3, negative 3 plus 1, that's negative 2. So you also get the value negative 1, negative 2. That's a point on this graph. So negative 1, negative 2 is right here. You can connect the dots. And that is the graph of k of x equals negative 6x squared minus 3x plus 1. If something's not readily factorable, if you're unsure it is, you could pick any other points on either side of your vertex, and then you can just connect the dots and plot it. So that's one way to do it. You don't always have to take the x-intercepts. It's just often easiest to do that, but it's more preferred that you do that, but you don't have to necessarily. Alright. Two more. F of x equals negative 2x squared plus x. So we have f of x equals negative 2x squared plus x. So find the x coordinate of the vertex. You'll have x equals the negative of b, which would be positive 1. So you have negative 1 over 2 times your a, which would be negative 2. Well, you'll have negative 1 over negative 4. So therefore the x-coordinate of the vertex is positive 1/4. So x equals positive 1/4. That would be the x-coordinate of the vertex. Now we need to find the y-coordinate, which would be done by putting in that 1/4 into the function. So f of 1/4 is equal to negative 2 times the 1/4 to the second power plus 1/4. Well, 1/4 to the second power is 1/16, so you'll have negative 2 times 1/16 plus 1/4, which would equal negative 1/8, plus, if we want to make 1/4 a denominator of 8, it would be 2/8. So what you have is negative 1/8 plus 2/8, that would just give you 1/8. So the vertex is going to be at 1/4, 1/8. That would be the vertex location. Would be at 1/4, 1/8. So that's going to be about darn near at 0, 0, but not quite. It's going to be about right there. That'll be the vertex. Alright, now let's pick a couple points here to plot, to draw to bring this parabola into fruition. And also, since this graph opens downward, since we have a negative coefficient on the x squared term, that value of 1/8 you got will be the maximum value of the function. Alright. Let's see, let's put in f of negative 1. That'd be equal to negative 2 times negative 1 to the second minus 1. Well, negative 1 to the second is positive 1, so you'll have negative 2 times positive 1 minus 1. which would equal -2 minus 1, which is -3. So you have the point -1, -3. So that works for a point on the graph, would be -1, -3. Now what if we put in +1? So we'll have f of 1 would equal, well, 1 to the second is 1. You'll just have -2 plus 1, which would equal -1. So you have the point 1, -1 that also works. There's 1, -1. Now we just simply got to connect the dots, and you have your parabola. That's f of x equals -2x² plus x. That would be the graph of that. And I have one more. Alright, let's just reconnect this graph a little bit. And I think that does it. Okay. H of x equals -1/3 x to the second plus 1. So we have h of x equals -1/3 x to the second plus 1. Well, let's find the coordinate of the vertex. So for the coordinate of the vertex, x equals negative of b, well, the b coefficient's always on the x to the first term, which we have none of. So that'd be 0 all over 2 times -1/3. Well, we can stop right there. Your x-coordinate of the vertex is going to be 0. So now we found the x-coordinate being 0 for the vertex. We want to find the y-coordinate. So you just put in 0 into the function. You'll take h of 0 equals -1/3 times 0 to the second plus 1. Well, I think it's safe to say the first term is 0. You just get 1. So h of 0 equals 1. Therefore, your vertex is going to be 0, 1. The vertex of this function is at 0, 1, which would be right here. All right. Now, what we have here is the vertex. We want to find at least 2 other points to graph. I would just take this function, set it equal to 0, -1/3 x² plus 1 equals 0, which would have to mean that 1/3 x² minus 1 equals 0. So then you would have, let's see, multiply both sides by 3, you get x² minus 3 equals 0. You'd end up getting x² equals 3, x equals plus or minus the square root of 3. So therefore your x-intercepts are going to be -√3, 0, and +√3, 0. Alright. Now let's see, -√3, that's a little bit smaller than -1, almost closer to -2, so that's going to go there. Then on the other hand, square root of 3 positive is greater than 1, a little bit less than 2, so that's going to go about right there. So now you just connect your dots and form your parabola. And that is the graph of h of x equals negative 1/3 x squared plus 1. So this has really been it for parabolas and quadratic functions. Next lesson is going to be a little bit different. We're going to start 3 lessons on variations. The next lesson will be direct variation. So I hope everybody has a good day. Take care.